everybody. My name is Shayan. This is Zach. That's Dave, and that's DJ. I was the leader. Zach was the software architect. Dave was the hardware architect, and DJ was kind of finding all the parts. So what our design is to do is to build a robotic arm controller. It's going to be attached to a 3D printed robot from the HBS labs. They have a lot of the other parts, and other groups are working on different parts, but our focus was on the arms. There's 3 different ways to activate these arms. They can either be activated by servo motors, or 2 different types of wires, TCP, twisted copolymer pipe wires, or SMA, shape memory alloy wires. So the goal is to use the NVIDIA Jetson TX2 to be able to control these actuators, either by setting the servo position or by applying a voltage to these wires. The way that the wires work is that they remember their initial shape, so that if they were elongated from the beginning, applying a voltage would make them contract and allow the fingers to actuate. We'd have 5 different actuators, 1 for each finger. And we'd also have sensors on each of the fingers, 1 for force and 1 for temperature, and there'd also be a temperature sensor on the palm. So the goal of this is to be able to help children in the future, and that's why this robot needs to be able to have all these sensors, and the user should be able to input data to the arm and have it be able to actuate in certain ways. So the way that our hardware is designed is so that the Jetson will actuate these actuators. They'll go to the hand, and the hand will give the sensor data back to the Jetson, and depending on that force data, the Jetson will continue to shape that trajectory for the force. The software is designed using ROS, which is the Robotic Operating System, and we wrote all our code in C++. And the idea is to modularize everything that we did. So for the software, we're writing all of them in different ROS nodes. And the reason for that is that by having that modular, they can send messages to each other. And in the same way that since we want to control 3 different actuators, it splits up the work. And if any future teams, we want to build this so that other senior design teams in the future can build off of this if they're building on the arms or any other part of the robot. So that's why even our hardware design, when we build the PCBs, we want to make it modular because there's alternate different ways that we can do this, and we also want to experiment with different ways. So we can use either for our thermistors, we can use PTC thermistors, FTC thermistors that either go up or down based on temperature, and we can also use op amps or in amps. So there's all these functional requirements, and since we're working with UTD labs, one of the focuses is the research, and they want to see how the different ones work. So not only will we be making one design, we'll be making about 4 or 5 different designs to just test how different ways the circuits can work with the hand and how different software can be implemented. Are there any questions?
You mentioned that this would interact with children. How do you ensure that it's safe?
So we do have some software requirements, some hardware specifications, so that when to not be able to go over certain voltages, not be able to go underneath a certain, and even when we were making the power requirements, we do have battery protectors and other current protection mechanisms so that there's no electrical, there's no fear of any electrical danger to the kids.
What about the actual hand, like squeezing someone's hands too hard?
Well, the grip strength is actually really low. I think it maxes around like 300 grams.
Can you walk in the car? Who did walk in the car? Who did walk?
So I was the leader. Zach was the software architect. David was doing hardware architecture, and Aditya was finding all the parts that we used, basically the sensors, and also the electrical components.
So you implemented all. So SPI, ITC, UART, what is implemented right now?
Mm-hmm.
So all.
So yeah, so the hardware architecture can use different components, and DJ was finding a lot of those different parts, and a lot of them use different communication protocols, and the same with a lot of different sensors.
Yeah. So the software diagram, not all the different protocols are going to be used, but we wanted the options to be there.
Could you describe what problem you're trying to solve by making this robotic hand? Like what is the use of your solution?
Well, right now the lab has already manufactured all the arms. They just don't have a controller for them, so that was the point of our experiment to be able to control.
Okay, so in your extent, we say it would be a creation robot that will be used for helping small children, but helping them to do what? Is what I was trying to ask.
They have we're not 100%, they haven't given us that in scope, but we were just told to be able to actuate them with different concept forces.
So it's,
okay, maybe destroy my ignorance of Jetson, but say I want to shake hands with it. How do you program it to shake my hand?
So we can, So far right now, the way that it works is that the user can either input a text file, a data file, to be able to show the exact trajectory of the force, right? Or you can select from a couple of presets. So we'd be able, if you wanted to have a shake hand program, you'd be able to program that, as one of the presets.
All right, I think we can thank the team.